For a brief moment, it looked as if something out there was watching us. The data came first, faint and quiet. A line of light that should have been chaotic appeared perfectly ordered. 3I Atlas, an interstellar object passing through our solar system, had begun to break apart. But instead of scattering randomly like a dying comet, its fragments spread in a straight, narrow line, evenly spaced, almost deliberate. To those studying it, it felt less like destruction and more like a signal. That was the first warning. Astronomers had seen strange visitors before. Oumuamua in 2017, Borisov in 2019. But 3I Atlas was different. It carried traces of both, a faint gaseous halo like a comet, yet movement patterns that broke every rule of cometary physics. It brightened too fast, then dimmed too early, and when it finally fragmented, it did so with precision that unsettled the observers. The first images arrived from the Pan-STARRS telescope in Hawaii. The shape of the debris seemed too neat, as if each piece had been placed where it belonged. Within weeks, observatories in Spain and Chile confirmed the same thing. The fragments weren't spreading outward in a random cloud, they were aligned. The official reports said little. Sequential disintegration events, one paper called them. Another referred to linear distribution of debris. But among those who had followed the data since Oumuamua, the language sounded cautious. They knew what it implied, an ordered process, not an accident. At first, no one wanted to say it out loud. The term artificial hung over the discussions like a shadow. It had appeared once before when Oumuamua accelerated in ways sunlight alone couldn't explain. That debate had faded without answers. Now, with 3I Atlas, it returned in whispers. The question that kept surfacing was simple, but impossible to prove. What if the breakup wasn't random? What if it was meant to be seen? For the public, 3I Atlas was a faint comet that came and went. Hardly anyone noticed when its light disappeared in mid-2020. But in the data archives, the anomaly stayed alive. Every image, every light curve, every fragment's motion remained under review. Over time, the pattern only became clearer. The intervals between breakups were consistent. The geometry of the pieces matched a repeating rhythm. To most scientists, it was still coincidence. To a few, it looked intentional. Those who had followed Oumuamua knew the pattern. An object from outside our solar system arrives unannounced, shows behavior that nature struggles to explain, and vanishes before anyone can investigate. 3I Atlas followed the same script. Only this time it broke apart right in front of us, as if leaving something behind. At the time of discovery, 3I Atlas was already fading. Its core had weakened from internal stress, sunlight, and spin. But its timing was strange. The disintegration started while it was still far from the sun, where ice should remain stable. That made no sense for a natural comet. Something else had triggered it. As each segment drifted apart, their spacing stayed constant, as though the object had followed an internal sequence. To an untrained eye, it was nothing, a few specks moving together. But to those measuring their light curves, the numbers spoke of order. The first person to notice was a postdoctoral researcher at the University of Maryland. She described the data as too synchronized. Her supervisor dismissed the idea, calling it an artifact of observation timing, but others noticed the same thing. The fragments weren't just similar in distance, they also reflected light at intervals that matched their separation in space. It was a one-to-one pattern. That was when one astronomer described it quietly as a mechanical signature. The phrase didn't appear in print, but it spread in conversation. If true, it meant the breakup of 3I Atlas might not have been caused by heat or rotation at all. It could have been the result of internal design, a structure coming apart in a planned sequence. No one claimed it was alien, no one dared. But privately, many wondered how many coincidences could pile up before randomness stopped being the simplest answer. By late 2020, 3I Atlas was gone. Its fragments faded from view, one after another. Telescopes tracked their paths until the light became too weak to follow. What remained was silence, data points scattered across databases, waiting for someone to make sense of them. Years later, when researchers revisited the event using improved analysis software, the results confirmed the same rhythm. The fragments had separated in time intervals consistent within a fraction of a second. The brightness of each piece corresponded to its position in line. No known physical process in comets produces that level of order. The conclusion was unsettling. If the breakup wasn't natural, it might have been intentional. And if it was intentional, it meant something, or someone, had reason to make it that way. Some speculated it could have been a probe, designed to disassemble itself once observed. Others suggested a relic of ancient technology, so eroded by time that its final act was mechanical decay. A few even proposed that the sequence was a kind of message, not in radio waves but in geometry, a warning written in motion meant for whoever might be watching. The idea was never published. It remained a quiet thought, traded between scientists after conferences, always prefaced with hesitation. But it lingered. The universe doesn't send warnings in straight lines by accident. When you look at the path of 3ES Atlas, it feels temporary, almost scripted. It entered from the direction of Cassiopeia, moving at 44 kilometers per second. Too fast to belong here, too slow to escape attention. It crossed the solar system once, left a trail of symmetrical fragments, and vanished. No return, no explanation. Maybe it was only rock and carbon dust torn apart by heat. Maybe it was something built long ago from materials that outlived their makers. Either way, its path left one message behind. Something passed through our sky, saw us looking, and decided that was enough. And then it was gone. After 3I Atlas vanished from view, the silence it left behind became louder than the data itself. For most people, it was over. Another comet, another mystery dissolved into the dark. But inside a handful of observatories, the story didn't fade. It deepened. The archived readings showed patterns that still refused to settle into any natural explanation. Each reanalysis brought the same unease. Every curve of light, every velocity trace looked like it belonged to something organized. The early explanations were practical, observational bias, timing errors, the limits of ground-based instruments. But those arguments grew weaker as more observatories compared records. The same timing pattern appeared across independent systems. The precision of it was what disturbed researchers most. It was too consistent to be coincidence, and too structured to be noise. Some began comparing the Atlas data to older interstellar events. Oumuamua's non-gravitational acceleration was the obvious reference. In that case, scientists had argued for an outgassing effect, sunlight pushing against invisible jets of gas. But 3I Atlas showed no strong signs of that. Its composition appeared too dry, its volatile content too low. So what caused the motion? If not gas, then something mechanical, something releasing energy from within would have to be considered. One group attempted to model the breakup using conventional stress analysis. Their simulations predicted a chaotic spread. Instead, the actual debris stayed aligned along a single vector. The more they tuned the model, the more artificial it began to look. To make it work, they had to assign tensile strengths and fracture points that followed a repeating internal layout like compartments. That alone didn't prove anything, but it hinted that 3I Atlas was not a uniform body. It had internal order. Around that time, a series of quiet conversations started circulating in astronomy forums and private channels. Most of the professionals stayed out of it publicly, but among those fascinated by interstellar material, the subject of intent came up more than once. No one suggested communication in the human sense. The term they used was structure with purpose, a way of describing complexity that behaves consistently, even after decay. The more they talked, the stranger it became. What if interstellar objects like 3I Atlas were not random debris, but relics of something else? Maybe not spacecraft, but remnants of larger systems once engineered and now adrift. Fragments that survived the death of their origin stars. Those ideas were never printed in journals, but the tension between theory and data remained. It was the same discomfort scientists had felt with Oumuamua's unexplained acceleration, now amplified by Atlas's symmetrical breakup. The universe was behaving as if someone had built it to get our attention, and we weren't ready to look closely. By 2022, new instruments tried to catch similar visitors. The Vera Rubin Observatory prepared for full operation, promising nightly sky surveys with unmatched coverage. The hope was to find more interstellar bodies, to compare patterns, to see if Atlas was unique. But even before those observations began, one unsettling discovery surfaced from the archived Atlas data. micro brightness variations that repeated in intervals of seconds, not hours. Too fast to be rotation, too faint to be background interference. It was a pulse embedded in the light. The pulse had no carrier signal, no radio emission, no measurable polarization. It was only visible photometrically, tiny oscillations in brightness, uniform across multiple instruments. The pattern stopped just before the object broke apart. To anyone unfamiliar with astronomical data, it meant nothing. But to those who had watched the fragments spread in geometric order, it looked like a countdown. The team that found the pattern didn't publish. Their funding relied on stability, not controversy. But private notes leaked between research groups. Each fragment appeared to have detached moments after one of those brightness peaks. The timing was too aligned to be accidental. For years afterward, the data remained buried in repositories, referenced quietly, never officially cited. The professional community stayed cautious. The phrase, self-limiting event, appeared in one paper. Another used internally driven fragmentation. These were the closest the field came to saying what some already suspected, that something inside 3i Atlas had controlled its own end. If that control was mechanical, it implied design. If it was natural, it revealed a physical process no one had seen before. Either way, it pointed toward a warning. Something that happened not by chance, but by rule. The concept of a warning didn't start in science. It grew out of intuition. Astronomers spoke about it privately, using words that didn't fit peer-reviewed language. The idea that we might have been observed through the event made people uncomfortable. Yet the evidence gave that discomfort shape. The alignment, the timing, the symmetry, it all resembled a demonstration, as if something had performed an act meant to be witnessed. One veteran astronomer put it plainly during an interview years later. He said, "If we were being watched, this is exactly how you would tell us, without telling us." He was half joking, but his expression didn't match the tone. After Atlas disappeared, telescopes turned elsewhere. New missions looked for exoplanets, for asteroids, for signals from space. But every so often, during analysis sessions, Atlas's name surfaced, again. Someone would mention the pattern, someone else would say it was coincidence, and the room would fall quiet. The object was gone, but the question remained. Did it arrive here by chance, or was its path chosen long before we had the means to see it? When its fragments drifted out beyond Mars, they continued moving in straight lines, each on a slightly different trajectory. Calculations suggested they would exit the solar system entirely, their speed unchanged. In time, they would vanish into interstellar space again, heading toward nothing we could trace. If the event was natural, the story ends there. But if it wasn't, then Thrutil. Atlas may have done exactly what it was meant to do. Appear once, reveal something subtle and leave without a trace. The simplest form of contact is a single gesture that doesn't need to repeat. We were being watched, and maybe, for one brief moment, we were meant to notice. The more researchers revisited the 3i Atlas data, the more they realized how incomplete their understanding of interstellar visitors still was. For every clean measurement, there were gaps, errors, and unexplained irregularities that refused to disappear. But one thing became clear. The event was not random noise in the universe. Something meaningful had happened, whether mechanical or natural, and it had left a pattern too deliberate to forget. In early 2023, a team in Chile reprocessed the original observation stacks using improved calibration algorithms. When they removed atmospheric interference and adjusted for instrument drift, a faint secondary structure emerged in the debris field. It wasn't linear this time. It curved slightly, forming an arc, a shape that seemed impossible if the fragments had only been flung outward by centrifugal force. The curvature suggested interaction, as though one side of the object had resisted motion for a fraction of a second before giving way. The finding deepened the puzzle. A natural body should fracture under stress along its weakest axis, producing an irregular fan of debris. 3i Atlas had done the opposite. It had fragmented along its strongest axis, as if preserving a final trace of symmetry before disintegrating completely. When the team shared their analysis privately, one senior astronomer compared it to a mechanical assembly separating under timed release. He didn't mean it literally, but the metaphor caught on. Soon the conversation turned from structure to purpose. If this was engineered behavior, what purpose could it serve? Some speculated that the event was an act of concealment, a way for a vessel or device to erase itself once its mission was complete. Others took a less dramatic view, perhaps 3. I-Atlas carried volatile pockets of frozen compounds that destabilized in sequence, imitating a controlled pattern without intention behind it. Both ideas fit parts of the evidence, but left other details unexplained. Among those who tracked the object's exit trajectory, another question surfaced. Why now? Why had 3 interstellar visitors, Oumuamua, Borisov and Atlas, appeared within a few short years after centuries of silence? The odds were astronomical. Statistically, Earth should see 1 interstellar object pass through every few decades, not 3 in less than 5 years. Either our detection capabilities had reached a threshold, or something had changed beyond our solar system. A few theorists suggested the latter. Perhaps something had disturbed the interstellar medium, shock waves from distant supernovae or gravitational disturbances near the galactic plane, nudging ancient debris toward our region of space. But others asked a quieter question. What if those objects weren't debris at all? What if they were travelers, launched in sequence long ago, each carrying different materials or messages? In most discussions, such thoughts stayed unspoken. Scientists preferred the comfort of physics over speculation. But the timing continued to haunt the data. Oumuamua arrived in 2017. 2 years later came Borisov, a natural comet. Then, only months after Borisov left our sky, 3 I-Atlas appeared. It was as if something had been approaching in stages. The public never saw the pattern because the events never connected officially. Each object was treated as an isolated discovery. Yet in research circles, the coincidence grew harder to ignore. If they were related, the sequence implied coordination, even if separated by light years and millennia. And if there was coordination, the thought of a message, however abstract, could no longer be dismissed entirely. By late 2024, the debate reached a quiet standstill. No one could prove design, but no one could explain the patterns either. The universe had given 3 examples, each stranger than the last, and then gone silent again. It left behind only questions. Still, there was one last clue hidden in the trajectory data of 3 Thorentine I-Atlas. As its fragments moved away from the inner solar system, 2 of them slowed slightly relative to the others, as if encountering a faint resistance. The effect was tiny, no more than a fraction of a millimeter per second, but consistent across multiple frames. When the data were adjusted for solar radiation pressure and gravitational perturbations, the slowdown remained. No known physical cause matched it. To most analysts, it was an error, a rounding artifact. But to a few, it looked deliberate. If the fragments were guided even minutely, it meant control. Control implied awareness, even if automated, and awareness on an interstellar scale meant intent. That was the point when one researcher wrote a single line in a private memo. The event behaved like a warning beacon, not a comet. No one published those words, but they appeared again in later notes buried in appendices, rewritten in softer language. Non-random fragmentation patterns suggest information potential. Sequential breakpoints consistent, with active modulation. It was the same thought disguised as data. When people speak about warnings from beyond, they often imagine direct contact, radio signals, flashes of light, visible proof. But maybe the real warning doesn't come that way. Maybe it comes as an object behaving slightly too precisely, showing up when we are finally capable of noticing. 3 I-Atlas might have been nothing more than stone and frozen carbon drifting through eternity. Or it might have been something older, something sent long before humans had telescopes or theories to explain it. A quiet visitor crossing the sky once, leaving behind a pattern we would only understand centuries later. The data doesn't tell us who or why. It only tells us we were seen. When Atlas vanished into the dark beyond Jupiter's orbit, the last recorded brightness showed one final flicker. Not strong enough to form a pulse, not structured enough to be a message, but it appeared at the exact moment the fragments crossed the limit of our detection range. A coincidence, perhaps. Yet to those who had watched it for months, it felt like a closing act, the last frame of a performance that ended the moment we looked away. We missed the meaning, if there was one. The warning may not have been a threat, but a reminder. We are not alone in this space, and whatever sent that fragment, whatever once shaped it, still exists somewhere beyond the light. When the light of 3I Atlas finally vanished from all known observatories, most scientists closed the case. Its trajectory was logged, its fragments catalogued, its mystery archived. But there were still a few who kept returning to the data, replaying the last frames, searching for the small things everyone else had missed. The silence that followed felt unnatural. It was as if the sky had gone quiet on purpose. Months after the last confirmed observation, a researcher at La Palma revisited archived exposures taken during the object's final days. Using updated correction models for atmospheric distortion, she noticed something no one had mentioned before. The light intensity from each fragment oscillated in pairs: 2 bright, 1 dim, 2 bright, 1 dim. The sequence repeated 8 times before fading completely. She double-checked for cosmic ray interference, satellite trails, anything that could fake the effect. Nothing fit. She showed the data to her supervisor. He smiled, shook his head, and told her to focus on something publishable. But she saved the files anyway. Later that year, she presented them quietly to a small conference in Geneva. The pattern caught the attention of 2 data analysts who specialized in optical modulation. They ran their own models, correcting for timing drift between telescopes. The same result appeared: 2 bright, 1 dim, repeating like a slow mechanical heartbeat. They didn't call it a signal, but the implication lingered. If the pattern wasn't natural, it could have been the residue of a process, a mechanism shutting down, or a fragment sequence completing its cycle. Whatever it was, the rhythm was intentional. By then, the broader scientific community had moved on. Attention shifted to newer discoveries, fresher data, other questions. The Atlas anomaly was seen as a curiosity from an era when interstellar research was still young. But the small group that stayed with it saw something different. They noticed how each interstellar visitor seemed to grow less visible and more controlled. Oumuamua had reflected sunlight chaotically. Borisov had behaved like a textbook comet. 3. Atlas, the last of the 3, had displayed the precision of a mechanism. The progression felt deliberate, like someone was adjusting the experiment with each pass. A few astrophysicists working off the record began to model what they called purposeful decay. The idea was that a vessel or device could disguise itself as a natural object until it no longer needed to remain intact. Then it would disassemble in a way that left no trace except geometry, a sequence of controlled breakpoints instead of wreckage. If such a system existed, it would be indistinguishable from a comet until the very end. The thought was unsettling because it was simple. You wouldn't need a message or a transmission or even a surviving machine. All you'd need is one pattern that repeats across time and space, visible only when a civilization learns to notice it. The astronomers who still studied 3I Atlas didn't claim to have proof. They spoke in hypotheticals, careful not to cross the line between evidence and speculation. But their tone shifted. What once sounded like distant theory began to sound like quiet acceptance. They no longer asked whether the breakup was natural. They asked why it happened when it did, and why it looked like an ending choreographed for us to see. If the object had been engineered, even in some ancient past, its creators were long gone. The fragments were inert, their orbits already drifting toward interstellar space, but the idea of a designed pattern lingered. Maybe 3. Atlas wasn't the first of its kind. Maybe it was one of many, each passing through a different system, releasing a final, silent performance before vanishing. The last human image of it came from a wide-field exposure taken in March 2020. The fragments appeared faint, almost invisible against the starfield. But when enhanced, they formed a shape faintly resembling a curve, like a line bending towards something unseen. That image became an obsession for a small team of graduate students who reconstructed the trajectory in 3 dimensions. When viewed from a different angle, the curve straightened again. It pointed, faintly, toward the same region of space from which the object had come, Cassiopeia. The finding was dismissed as coincidence, yet for those who believed the pattern mattered, it looked like a gesture, as if the object was pointing back home. The years that followed, the story of 3I Atlas faded from the news cycle. It remained a topic of conversation only among enthusiasts, late-night forums and researchers who still felt that something had been overlooked. A few papers revisited its composition and decay rate, all ending with cautious language, inconclusive, unresolved, requires further study. The mystery was officially unsolved, unofficially unforgettable. To those who still cared, the warning wasn't in the data itself but in what it represented. The universe is ancient, and civilizations, if they exist, would not need to shout to be heard. They could speak in physics, in patterns of motion, in the quiet logic of geometry. A civilization advanced enough to travel between stars might prefer to remain unseen. But it might still leave messages, woven into the natural order, waiting for someone else to reach the point of recognition. If that is true, then 3. Atlas may have been our first lesson. Not a threat, not a greeting. Just a reminder that observation goes both ways. When you watch the sky, you imagine you're looking outward, into the unknown. But what if the unknown has been looking back, waiting for you to notice the pattern? The thought doesn't need proof to unsettle you. All it needs is silence and the memory of a light that flickered once and never returned. For most of human history, the sky has been a mirror of imagination. Every point of light has carried a story, a warning, or a hope. But what happened with 3i Atlas changed the way some scientists look at that mirror. It reminded them that the universe might not only reflect, it might respond. The first serious discussion about intent in celestial motion began quietly. A research group at the Harvard-Smithsonian Center for Astrophysics analysed all known interstellar objects in a single dataset. They expected randomness. What they found instead was faint clustering in arrival vectors, as if each object had entered our solar system along trajectories that were not entirely uncorrelated. Statistically, the result was weak, but it was there. One of the astronomers phrased it carefully during a seminar. If the universe sends visitors, we've met 3, but if someone else sends them, we've only just noticed. The statement drew no laughter. The room was silent. Soon the discussion turned to probability. The odds of 3 confirmed interstellar objects within a 5-year span were less than 1 in several thousand. Natural or not, something had changed in our galactic neighbourhood. Either we were passing through a region of denser debris, or objects were being directed here. Both explanations were extraordinary. Another researcher suggested a less dramatic idea, that our instruments had reached the sensitivity threshold needed to detect what had always been there. But even that raised its own unease. If these objects had been crossing through unnoticed for eons, how many had come and gone while no one was watching? And how many might have carried the same strange order as 3i Atlas? At the same time, others began connecting cultural patterns to the data. Throughout history, moments of cosmic alignment or celestial events had often coincided with social anxiety. Comets meant warnings. Lights in the sky meant attention from something greater. Now, with the tools of modern science, humanity was once again standing beneath a sky that seemed to answer back. By 2025, small amateur networks started tracking what they called interstellar anomalies. They combined data from open observatories, filtering faint detections of fast-moving objects on hyperbolic paths. Most turned out to be false positives, camera noise, satellite glints, sensor ghosts. But a few didn't fit those categories. They moved too straight, too steady, and then disappeared after a handful of nights. The professionals stayed cautious, but the growing archive of unexplained visitors reopened the question: was 3i Atlas unique, or was it the first we noticed clearly enough to wonder? When journalists approached the original Atlas research teams for comment, most declined. They were tired of the speculation. To them, 3i Atlas was still a fragile comet, nothing more. But in interviews off the record, their tone changed. They spoke about its timing, its structure, its rhythm. They didn't use words like artificial anymore, but they didn't call it coincidence either. One scientist described the breakup as an intentional silence. When asked what that meant, she said it was the quiet left when something has already said everything it needs to. Among the few who followed her reasoning, the meaning was simple. The warning we missed wasn't an alarm. It wasn't a threat. It was awareness. The realization that someone, somewhere, already knew we were here. After the final data releases, the Atlas project shut down. Funding moved to new priorities: asteroid defense, exoplanet imaging, and the search for biosignatures in nearby systems. Yet, in quiet corners of research servers, archived folders labelled Atlas 3i remained untouched. Some contained incomplete simulations, others raw light curves. A few held personal notes, never meant for publication. In those files, you could see the transition between curiosity and disbelief. Lines that began with "unlikely coincidence" ended with "requires further review." Those notes read like confessions. If you were to open them today, you would find the same questions repeated. Why now? Why so precise? Why so silent? Each line of text captures the tension between data and understanding, between science and intuition. The answers were never written because they didn't fit the language of science. Still, the researchers knew what they had seen. A pattern that looked like design, a sequence that felt like timing, a disappearance that arrived too perfectly to be random. Over time, the world forgot. The sky filled with new data, new events, new headlines. 3. iAtlas became a footnote in the early era of interstellar observation, but the feeling it left behind, the sense of being observed, never disappeared. That feeling reshaped how astronomers approached the unknown. The next generation of researchers no longer dismissed order as coincidence. They studied it, mapped it, learned from it. They understood that nature itself can mimic intention, but they also knew that intention can hide within nature. When they pointed their telescopes toward the deep sky again, they didn't just look for movement, they looked for rhythm. Years later, one of those astronomers described the change in mindset with quiet simplicity. He said, "We stopped assuming we were the first ones to notice." The warning, it seemed, had worked after all. Not long after 3 iAtlas left the solar system, the debate surrounding it began to split into two distinct camps. One side treated it as a cosmic anomaly, a comet-like body shaped by forces too complex to model, but still natural. The other believed it was something far older, evidence of an intelligence that no longer existed or no longer cared to reveal itself. Neither side could disprove the other. The data sat in between, cold and silent, immune to interpretation. Among those who leaned toward the second view was a researcher named Elena Rios. She had been part of the early observation team at Mauna Kea. When funding dried up, she kept working privately, studying every archived exposure she could access. In 2026, she published an independent report that drew little attention at first. It focused on thermal irregularities recorded just before 3 iAtlas began to fragment. Her analysis showed that the heating across the object's surface wasn't uniform. Instead of warming gradually as it rotated, certain regions pulsed in short bursts, as if energy were being released in controlled intervals. The bursts didn't match sunlight exposure or rotation rate. They matched timing sequences from the object's own brightness data. In other words, the pattern wasn't random, it was synchronized. Rios stopped short of suggesting artificial origin. She called it energy modulation. But the implication was clear enough. The object had behaved like something managing its own decay. The scientific community responded politely but distantly. Reviewers questioned the calibration methods, the noise reduction model, the interpretation. Yet even the harshest critiques admitted the results were intriguing. Nothing quite like that had been seen in another interstellar object. The report was archived, cited a handful of times, and forgotten by most. But a small group of astronomers didn't forget. They began running comparative simulations to test whether a natural nucleus could reproduce those signals. The answer was negative. Every model based on thermal stress, rotation, or volatile pockets produced randomness. The regular intervals remained unexplained. One night, during an informal discussion after a conference in Arizona, one of the team members asked a question no one wanted to answer. If 3 iAtlas wasn't behaving like a comet, what was it behaving like? The room fell quiet. Someone eventually said, "Like a countdown." It was a simple remark, but it changed the tone of their work. They started viewing the data differently, aligning light curves against possible sequences, searching for repetition. Over months, they found faint echoes, intervals of modulation repeating every 18 minutes in the final phase of observation. Each pulse matched the timing between fragment releases. The finding didn't make sense. The object was too small to contain any mechanism, and its composition didn't support such regular thermal behavior. The pulses weren't strong enough to propel or spin it, but they were clear enough to detect. It was as if something within 3L1 iAtlas was marking time before failure. When the group wrote their private summary, they avoided dramatic words. They called it structured decay. but among themselves they referred to it differently. They called it the warning signal. The phrase stayed private for years, never entering any publication. Still, it appeared in emails, notes and logs, always lowercase, always unspoken in presentations. To them it wasn't a claim, it was an observation. The object broke apart only after completing a repeating thermal pattern. Whether natural or not, that pattern seemed deliberate. As the years passed, the fragments of 3I Atlas drifted farther from the Sun, crossing the orbits of the outer planets and fading into interstellar space. One by one, tracking systems lost sight of them. By 2027, all contact was gone. The fragments were invisible to every telescope on Earth. Yet the idea didn't fade. Other research teams began revisiting similar data from past events, wondering if smaller interstellar fragments had shown comparable patterns. In a few scattered datasets, they found faint signs of rhythmic behavior, tiny light oscillations repeating for short periods before fading. None were as strong as the Atlas signal, but the resemblance was there. It was enough to shift the conversation. For the first time, a few journals began using the term structured disintegration. The phrase was neutral, vague enough to avoid controversy, yet it acknowledged the possibility that some interstellar objects behaved in ways too ordered to be purely mechanical. Rios never claimed to have found proof, but in a later interview, when asked what she believed 3I Atlas had been, she paused for a long time before answering. Then she said, "Something that wanted to be seen exactly once." Her words echoed the sentiment of others who had studied the event closely. The 3I Atlas hadn't arrived to announce itself. It had arrived to test perception, to reveal how closely we were watching. And when we noticed, it ended. The question that lingered was whether that ending was its goal all along. If it was, the warning wasn't in what happened, but in what followed. Since its departure, Earth's sky has been full of motion. Thousands of new objects discovered each year. But none have behaved like Atlas. It remains unique, a single event in human observation that hinted at awareness without proof. And that may have been the point. Awareness without proof keeps you watching. It keeps you looking up. In the absence of explanation, mystery becomes the most efficient form of communication. The scientists who still monitor interstellar objects know this feeling well. They no longer expect messages or signs of life. Instead, they wait for anomalies, irregularities too stubborn to ignore. Because they understand now that the universe doesn't need to speak to be heard. It only needs to break pattern once. 3. Atlas did exactly that. It broke, it signalled, and it vanished. It left behind no debris, no answer, only the sense that something out there knows we're watching, and has been watching us longer than we realise. The years following the disappearance of 3I Atlas changed how humanity watched the night sky. Observatories became quieter, more cautious. Reports were written with softer language, filled with qualifiers like unlikely, possibly, and further investigation required. Yet underneath the restraint was something new, an awareness that the line between observation and participation had blurred. When you watch the universe closely enough, you begin to suspect that something is watching you back. By 2028, a new generation of astronomers was working on the next wave of sky survey instruments. Many of them had grown up reading about 3I Atlas as a scientific curiosity that flirted with myth. They wanted proof, or at least repetition, another visitor to compare against the impossible symmetry of Atlas's final hours. But no new interstellar objects behaved the same way. They passed quickly, ordinary in every sense. For a while, people started to think that Atlas had been a once-in-history event. Something rare, unrepeatable, and irrelevant to anything larger. But a few researchers didn't let go. They began tracing backward through old survey archives, looking for pre-digital records of fast-moving faint comets that might have fit the same profile. Most of those records were incomplete, but one in particular stood out, a faint object, photographed in 1986, that followed a hyperbolic path almost identical to Atlas's, originating from the same region near Cassiopeia. The object had been dismissed at the time as a transient image defect, film grain, static, or perhaps a meteoroid caught mid-burn. But the coordinates matched. If the data were accurate, it would mean that another body, possibly a companion to 3I Atlas, had passed by nearly 40 years earlier. The discovery never made headlines, but it circulated among specialists. Some called it coincidence, others called it precedent. If true, it suggested that 3i Atlas was not a solitary traveller. It was part of a sequence. And if the sequence was real, then the next visitor was already on its way. That thought began to circulate in private discussions by early 2029. Small, quiet threads appeared in scientific forums, hypothetical arrival windows, trajectory predictions, speculation about timing cycles. None of it had evidence, but the possibility drew attention. What if the visitors followed a rhythm not measured in years, but decades? A galactic heartbeat we were only now learning to hear. No one claimed this openly, but private notes show that some observatories began running passive monitoring protocols. These were sky surveys, optimized not for detection, but for response, waiting rather than searching. Watching regions of space where nothing should happen to see if something might. That patience soon produced a new kind of silence. It wasn't the absence of data, but the weight of expectation. Every quiet night felt like a held breath. Meanwhile, a few astrophysicists returned to what the 3i Atlas data implied about the object's structure. If it had fractured intentionally, then something inside it had obeyed a set of rules. And if those rules were mechanical, they could be replicated. One simulation modelled Atlas as a hollow shell with nested layers that failed sequentially under heat exposure. When animated, the layers peeled back in perfect symmetry, like petals unfolding and dissolving. The effect was strangely beautiful and unsettling. One of the team members remarked that it looked like a device releasing itself. After that simulation was shown at a closed seminar, the term release object started circulating in documents. A release object was defined as any body whose destruction transmitted geometric or energetic information. Whether natural or designed didn't matter. The result was the same: information hidden in decay. When that idea spread, something shifted in how people talked about space. It wasn't only about searching for signs of life anymore. It was about recognizing patterns that didn't fit, movements that looked staged. The calm rhythm of science began to carry a trace of suspicion. By 2030, several of the astronomers who had studied 3i Atlas were no longer working in research. Some left quietly, exhausted by years of skepticism and the endless need to explain what couldn't be explained. Others stayed, publishing under different topics: thermal dynamics, dust modelling, optical scattering, but their names were still whispered whenever anomalies appeared. They had become part of the mythology of the modern sky. Then, early one morning in June 2030, an automated telescope array in South Africa detected a faint object entering from the northern hemisphere. Its trajectory was hyperbolic, descending from Cassiopeia. The signal-to-noise ratio was poor, but the velocity was almost identical to Atlas's, 44 kilometers per second. The system flagged it automatically as potential interstellar. The next night it disappeared from view. When the detection was announced days later, some scientists called it noise, a glitch caused by camera misalignment. Others froze when they saw the data. The timing fit the pattern almost perfectly. 4 decades after the object photographed in 1986, 10 years after Atlas. If the sequence held, the next arrival would follow in another 10. The event reignited every buried argument. News outlets reported it briefly, framing it as coincidence. But in internal channels the tone was different. Teams began scheduling observation windows, recalibrating instruments, preparing for another visitor that might never come. There was no proof yet, only a number and a direction. But for those who had studied 3i Atlas, it was enough. They didn't see it as discovery. They saw it as continuation. Something had passed through once. Something might be passing again. And if the pattern was a warning, then this time humanity was ready to listen. The announcement of the South Africa sighting stirred something that had been dormant since 3i Atlas vanished. At first, it was quiet curiosity. Then, as independent astronomers confirmed fragments of the same data, curiosity turned to unease. The coordinates matched too neatly, the velocity too exact, the path too familiar. It was as though the same object had returned, or its twin had arrived to finish what the first began. In public statements, officials called for restraint. Space agencies emphasized that the evidence was incomplete. The detection had been faint, the tracking brief, the object lost after only one pass. But the researchers who remembered Atlas knew what they were seeing. The numbers were too close to coincidence. The object's approach vector aligned within a single degree of the original Atlas trajectory. Even its predicted solar encounter distance matched. The quiet question that had haunted scientists for a decade surfaced again. Were we being watched, or were we being studied? If this new visitor was connected to 3i Atlas, then perhaps the first had not been a warning after all. Perhaps it had been a test, to see whether we noticed, to measure how carefully we would look when something similar happened again. For several weeks, observatories tracked the region of sky where the new signal had vanished. There was nothing, no light, no reflection, no trace of debris. Yet radio telescopes began to report something else, a background noise slightly elevated above normal levels, faint but consistent. It wasn't a signal in the conventional sense, it was more like static that carried structure. The fluctuation repeated every 90 seconds, too regular to be random, too weak to localize. At first, analysts attributed it to interference from nearby satellites, but when the same rhythm was detected by stations thousands of kilometers apart, the theory collapsed. The timing matched perfectly. One researcher plotted the sequence over the Atlas fragmentation data from 10 years earlier. The pattern aligned 90 seconds. The same rhythm that had marked the final stage of 3i Atlas's breakup was now echoing through background noise from the same region of sky. No official report mentioned it. The findings were classified as instrumental coincidence. But the raw data, once released to civilian networks, told a different story. Amateurs who had followed the Atlas mystery saw the repetition immediately. To them it looked like confirmation. Forums filled with speculation. Some believed the objects were probes, moving in formation across decades. Others thought they were messages sent in physical form, massive carriers travelling through space to deliver geometry instead of radio. The cautious minority argued for coincidence, but their voices were drowned out. The more people analysed the data, the stranger it became. The rhythm wasn't constant. Every 7th cycle, the 90-second interval shortened slightly, then returned to normal. That variation matched a faint optical pulse recorded during the final observation of 3i Atlas back in 2020. The alignment was exact to within milliseconds. To the few remaining scientists still following the case, this was the turning point. The event no longer fit any natural model. Objects do not synchronize across decades. Random debris does not pulse in time with ancient light curves. When questioned, one astrophysicist summed it up quietly. If this isn't communication, it's something more unsettling. It's observation. The data faded after a few weeks, replaced again by silence. But the silence felt heavier this time. It carried the memory of structure, the echo of something repeating just long enough to be noticed. Then, one night, a telescope in Japan caught a brief streak across the region near Cassiopeia. The exposure lasted less than 2 seconds, but the colour signature was identical to the spectral traces of 3i Atlas, a faint cyan-green hue caused by carbon emission under low solar flux. The trajectory indicated it was moving away, not toward the sun. Another departure. To the teams that still cared, it felt like closure and confirmation at once. Something had been there. Something had watched, measured, and left. In the following months, research shifted quietly. The term Atlas-class interstellar object appeared in proposals. These were defined as bodies exhibiting controlled fragmentation, recurring trajectories, or harmonic emission. The language remained clinical, detached, but the implication was clear. We were beginning to catalogue a behaviour that science had no framework for explaining. In the next international conference on near-Earth objects, an entire session was devoted to non-random, interstellar trajectories. The presentations avoided speculation, but the tone was different now. There was less skepticism, more restraint. The idea that the universe might contain engineered relics was no longer dismissed outright. It was simply unconfirmed. For many of the younger researchers, this shift felt normal. They had grown up in an age when the line between natural and artificial had blurred across every field, from AI to astrophysics. To them, a self-decaying interstellar body was strange but plausible. The older generation found it harder to accept. To them, Atlas had been a wound in understanding, a question they couldn't close. Years later, when the Japanese streak image was reanalyzed, one faint detail went unnoticed in most reports. The streak had a small flare halfway along its path, a subtle widening in brightness. When translated into positional data, the flare corresponded exactly with the point in space where 3i Atlas had first begun to break apart. As if, even in departure, the new visitor had chosen to repeat the motion. If that was deliberate, then the message was simple. You saw what we wanted you to see once before, and you're seeing it again now. Whether that message came from design, coincidence, or something we still can't name, it changed the story forever. The warning wasn't about danger, it was about attention. Someone, or something, was reminding us that in this galaxy of silence, observation is mutual, and that was enough to keep humanity looking up, waiting for the next fragment to cross the night. By the early 2030s, the Atlas story had drifted into legend. Among professionals, it was a cautionary tale about data interpretation. Among the public, it became a quiet obsession. People watched the sky again, not for beauty but for pattern. The idea that something out there had noticed us was no longer fringe. It was an unspoken possibility woven into late-night documentaries and classroom discussions. The reappearance of another object from Cassiopeia had reignited that feeling. It reminded everyone that the sky could change overnight. Scientists learned to speak carefully when addressing the public. Words like anomaly or structure were replaced with unmodelled behaviour. The tone remained calm, factual, but the eyes behind the microphones always looked uncertain. It wasn't fear, it was recognition. Humanity had seen enough to understand that the unknown could be structured, deliberate, even patient. At the same time, a new generation of instruments was coming online. The Rubin Observatory's surveys became fully operational, capturing thousands of transient events per night. Every week, software flagged dozens of objects with trajectories that seemed unbound by the sun. Most were camera artifacts, a few were distant asteroids, but occasionally something didn't fit. And every time that happened, 3i Atlas was mentioned again. One small team in Australia began compiling these anomalies. They cross-referenced velocity, direction, brightness modulation, and decay patterns. After 3 years of data collection, they found that a handful of faint objects, too dim for casual detection, shared a common feature. Each one passed through the solar system at nearly identical inclination angles. When those paths were projected backward, they all converged near Cassiopeia. Statistically, the odds of that alignment were almost impossible. The discovery never made it into major publications. The data was too uncertain, the measurements too fine to verify. But within that team, the conclusion felt unavoidable. The Atlas event wasn't singular. It was part of a corridor, an invisible lane through which multiple interstellar bodies had passed over decades, perhaps centuries. They called it the Cassiopeia track. The Cassiopeia track changed everything about how they looked at interstellar space. If the corridor was real, then these objects weren't wandering. They were navigating. That word, navigating, appeared once in an internal note before being removed from every draft thereafter. It implied intent, and intent required intelligence, but it stayed in people's minds. Soon after, a strange phenomenon began appearing in long-exposure telescope images taken near the track. Faint linear shadows, subtle distortions in the background starlight, moving across exposures taken hours apart. At first, they were dismissed as imaging errors, but when the same distortions appeared on multiple instruments across different continents, the dismissal no longer worked. The lines seemed to move too slowly for meteoroids, too predictably for sensor noise. They curved gently toward the same outbound region where 3i Atlas had vanished. One astrophysicist compared them to contrails, remnants left behind by something invisible. When he shared that thought at a conference, the room went silent. He laughed it off, called it poetic exaggeration, but no one else did. By then, the Atlas phenomenon had already changed the language of astronomy. Observation logs began including a new field labelled non-gravitational vector deviation. It was a catch-all phrase for motion that didn't fit the equations. It appeared first in one report, then another, until it became standard form. The field rarely contained numbers. Usually it contained a single word, Atlas. In 2033, an independent network of amateur astronomers reported a slow, continuous drop in background light intensity near Cassiopeia. Over months, they measured a faint but consistent dimming across a wide area, too gradual for a nova, too uniform for dust. To them, it felt like a shadow spreading. Professional observatories dismissed it as calibration error. but the amateurs kept measuring. By autumn, the effect covered several degrees of sky. Then it stopped. No event followed. No explosion. No arrival. Just stillness. To some, it looked like nothing more than atmospheric interference. To others, it was the echo of movement, something vast passing between us and the stars without leaving a trace. At the same time, low-frequency radio telescopes picked up irregular pulses near the Cassiopeia track. The signals were too faint to decode, buried under noise, but they shared one distinctive feature. Every seventh pulse shortened slightly before returning to rhythm. The same pattern again, 90 seconds minus 1. It was no longer possible to claim coincidence. Too many systems, too many instruments, too much repetition. The same rhythm had followed 3i Atlas across decades and across technology. Whatever was causing it was persistent. Still, no one could explain it. Every theory led back to the same impasse. If it was mechanical, it shouldn't last this long. If it was natural, it shouldn't be this precise. And if it was communication, it was too simple to translate. Eventually the signals faded as the dimming ceased. The region of Cassiopeia returned to normal brightness. The observatories moved on, the conferences resumed, and the silence reclaimed the discussion. But something fundamental had changed. The watchers, the humans, had learned to listen differently. They understood now that messages don't always use words. When a body breaks apart in perfect rhythm, when light flickers every 90 seconds across decades, when fragments leave the solar system on the same line of departure. Those are forms of speech too. The Atlas sequence may never be decoded, but its meaning doesn't need translation. It was attention drawn toward itself, then withdrawn, like an eye closing after confirming what it wanted to see. For years, scientists tried to resist that interpretation. They called it romantic, unscientific, anthropocentric. But when the data kept returning, even they began to describe it differently. They no longer said, the object behaved. They said, it responded. That was when the realization took hold. The warning we missed wasn't about danger, it was about acknowledgement. We had looked into the dark, and something in the dark had looked back. After the Cassiopeia dimming ended, there was a long stretch of silence. No new anomalies, no unexplained signals. It was as if the sky had taken a deep breath and then decided to hold it. But that quiet carried tension. The sense of being watched had turned from speculation into habit. People no longer wondered if something was observing. They assumed it was. Governments took the shift seriously, even if they didn't say so publicly. Space agencies started running new observation programs under names that sounded ordinary: deep survey, trajectory analysis, spectral study. But their purpose was clear: to monitor the corridor near Cassiopeia around the same time each year. They weren't just searching, they were waiting. The first to notice something different were radio engineers in Canada. In 2034, while calibrating an array for a deep space communication test, they detected a recurring distortion at frequencies just below human hearing range. It wasn't a signal in any familiar form. It was a modulation of background radiation itself, fluctuating between noise and order every few hours. The cycle lasted exactly 9 days, then stopped. When the readings were compared to orbital calculations, the alignment was exact. 9 days before the 10th anniversary of 3i Atlas's disintegration. Once again, the pattern had returned. There was still no visible object, no light, no reflection, only an echo in the noise, an unseen presence marking time with mathematical precision. The data reached research centres in Europe within hours. Every major observatory redirected its instruments toward Cassiopeia. Nothing appeared, yet in the radio background the pulse continued faintly, repeating the same subtle compression every 90 seconds. Some called it the final proof, others called it the universe clearing its throat. The pattern lasted for 11 days, then stopped completely. But when the data was averaged over time, something unexpected appeared. The intervals between compressions weren't identical. They followed a slow progression, each slightly shorter than the last, forming a logarithmic curve that pointed toward a future date. When projected, that date landed exactly 10 years later, the year 2044. The implication was simple and terrifying. The pattern was counting down. The first warnings appeared in internal memos. Teams debated whether to release the data. Some argued it was coincidence, the result of instrument drift. Others said ignoring it would be worse. Eventually, a small summary was published in a minor journal under the name Temporal Compression in Cosmic Microwave Background. The description was vague enough to go unnoticed, but the numbers were there for anyone who looked closely. In online communities, they noticed. People began to talk about the date, quietly at first, then with growing conviction. If the countdown was real, something would happen in 2044. Theories multiplied. Some predicted another interstellar visitor. Others feared a catastrophic event. Most assumed it would pass without incident. But everyone agreed on one thing. It felt deliberate. Astronomers tried to remain calm. They reminded each other that patterns emerge easily from randomness, that human perception is built to find meaning where none exists. But this wasn't imagination. It was measurement. Instruments across continents had seen the same rhythm in the same part of the sky with the same timing signature as Threthalnd as Atlas. As the years went on, the countdown became background noise in both science and culture. Documentaries referred to it as the Atlas interval. Talk shows debated its meaning. Novelists turned it into allegory, and through it all the pulse continued faintly, constant and patient, as if waiting for its own deadline. By 2039, the signal's frequency had shifted higher. What had once been a whisper in the noise was now a measurable rise in local radio background near Cassiopeia. The shape of the curve remained exact. At its current rate, the final interval would occur in mid-2044. For scientists, the waiting became unbearable. You can observe a mystery only so long before it begins to observe you back. In 2042, a joint mission was approved, Project Vigil. Its purpose was to send a deep space probe into the projected region of the Cassiopeia track. The plan was simple: intercept whatever might appear, record everything, and transmit it home. The probe was equipped with a compact nuclear engine, long-range imaging arrays, and a continuous transmitter. Its estimated travel time to the observation zone was 16 months. It launched quietly, without public attention. Only a few thousand people even knew it existed. Halfway through its journey, the signal changed again. The 90-second rhythm ceased. In its place came a continuous rising oscillation, subtle but measurable. It was no longer a pulse, it was a tone. Onboard instruments of Project Vigil detected it first. The probe's sensors recorded the oscillation as a slight interference in its communication band, like static that shaped itself into a repeating curve. Ground control analysed it, looking for origin. It came from ahead, not behind. Then the oscillation stopped. Telemetry continued normally for another 12 hours. Then the probe went dark. No damage reports, no power warnings. Every channel went silent at once. For 2 days, Mission Control tried to re-establish contact. Nothing returned. The last transmission contained only a partial image, a faint green-tinted frame filled with scattered points of light. Most dismissed it as noise compression failure. But when enhanced, the points aligned into a familiar shape, a straight line of 7 dots, 7 fragments. The same formation recorded during the final moments of 3i Atlas. The image became the last piece of data ever received from Project Vigil. The probe was declared lost, the mission terminated, and all future exploration of the Cassiopeia region suspended indefinitely. Publicly, the event was described as equipment malfunction. Privately, it was treated as confirmation. The countdown had ended and something had answered. Since then, no new signals have been detected from that direction. The sky has gone quiet again, perhaps for another decade. But those who still remember 3i Atlas know that silence isn't safety, it's part of the pattern. Because in this story, the message was never in the sound. It was in the waiting. The disappearance of Project Vigil marked the end of open observation. Afterward, the sky became something guarded, spoken about in numbers rather than stories. Research shifted towards silence, less public release, more classified archives. But even without new data, the feeling of presence never left. The people who had once studied 3i Atlas grew older, their careers scattered across other projects. Some left astronomy altogether. Others continued their work in quieter corners, teaching, writing, or simulating what might have happened to the lost probe. Yet every few years their paths crossed again in small conferences or private correspondence. Each time, the same question returned. What if Vigil had seen something that chose not to be recorded? The debate had become philosophical. If a message is received but can't be understood, does it still count as contact? And if contact occurs once, silently, what happens when it happens again? By 2045, the world had adjusted to the absence. New discoveries filled the headlines: habitable exoplanets, faint biosignatures, strange radio bursts from distant galaxies. The Atlas story faded into the background, filed away as an unsolved anomaly. Only a few people kept watching the coordinates. One of them was a retired systems engineer named Rios, the same woman who had first identified the energy modulation years earlier. She kept her own telescope array in the Chilean desert, calibrated precisely to the Cassiopeia corridor. Every night she recorded sky frames, not out of hope, but out of habit. Then, one evening in late 2046, she noticed a faint light where there shouldn't have been one. It wasn't bright enough to be a comet, not fast enough to be debris. It moved slowly, deliberately, crossing the same patch of sky where 3 Atlas had once entered the solar system. She logged the coordinates, checked against existing databases, and waited. 2 nights later, it was still there. The movement was steady, but the direction was reversed. It wasn't entering. It was leaving. The object emitted no tail, no gas, no radiation spike. But every 90 seconds, its brightness dipped for half a second, then returned. The same rhythm, the same silent heartbeat that had haunted every observation for decades. Rios didn't announce the discovery immediately. She spent a week verifying it herself. By the time she contacted an observatory in Argentina for independent confirmation, the object had already faded below detection limits. The team found nothing. For most, that would have been the end of it. But for her, it was closure. After years of watching, she understood. The Atlas sequence had not been a warning of danger. It had been a demonstration, a way of showing that the watchers could appear and disappear at will. The object leaving Cassiopeia was not coming toward us. It was moving home. In her final paper, published privately, Rios wrote a single line that summarized decades of observation. Awareness travels both ways. The paper never circulated widely, but those who read it recognized its meaning. It was the last echo of an idea too large for certainty, that intelligence does not always reveal itself through language or technology, but through rhythm and attention. The disappearance of 3I Atlas had made us notice. The return of its echo had made us listen. The rest was silence, and in that silence, understanding. Humanity's telescopes continued to scan the sky. New instruments, larger and more sensitive, filled the deserts and mountaintops. They searched for planets, stars, motion, anything measurable. Yet somewhere beneath the data, another purpose had taken root. Every image, every signal, every faint flicker of light was now viewed through a quiet thought. Are we being watched again? In time, the Atlas event became less a scientific mystery and more a story. A reminder that observation is never one-sided. Students read about it as history. Scientists referenced it cautiously. But for the few who had felt the unease of seeing those fragments stretch in perfect symmetry, the memory never faded. The final irony was that the warning had been gentle all along. No invasion, no threat, no harm, only precision, a calm, deliberate pattern, a message that said, "You're not alone, and you were never first." In 2048, on the 28th anniversary of 3 Atlas's discovery, the European Space Agency released a commemorative dataset, every observation compiled into one digital archive. It was intended for research, but most who opened it did something else. They scrolled to the last image, the one from Project Vigil, the frame filled with faint points of green light. When viewed without enhancement, the points looked random, but if you overlaid them on the original Atlas trajectory, the alignment was exact. 7 points, in a straight line, marking the same direction back toward Cassiopeia. No one could explain how a probe lost far beyond the solar system could produce such precision. But perhaps explanation was never the point. The archive ends with that frame. Beneath it, a single annotation from the mission director remains. Object responded in kind. No other entry follows. Today, the coordinates of the Cassiopeia track are still watched nightly by automated telescopes. They record nothing unusual. The sky above them looks the same as it always has. But those who understand the history know better. Silence is not absence. Silence is patience. And patience, in the language of the cosmos, may be the oldest form of communication there is. The stars look the same now as they did before 3i Atlas appeared. The same constellations, the same quiet spread of light, the same deceptive stillness that makes the universe feel distant. But once you've seen an object move with intention through that stillness, you never see it the same way again. Every flicker becomes a possibility. Every silence feels like a pause between words. In the decades since, astronomers have learned not to speak about the event directly. It survives in side notes and passing references, in data files labelled with neutral language. Yet its influence is everywhere. It changed how we listen. It changed what we consider possible. Modern observatories now use algorithms tuned to find rhythm instead of brightness. They search for order, patterns that repeat across years, across frequencies, across instruments. They were designed to find exoplanets, but what they're really looking for is recognition. Somewhere in the unending data, they are waiting for that 90-second interval to return. It hasn't yet. But that silence has its own weight. The scientists who lived through the Atlas years have mostly retired. They leave behind recordings, papers, and small notes that never entered the official record. Some of those notes sound less like research and more like reflection. They ask questions without expecting answers. Did 3i Atlas act alone? Was it part of something larger? And if so, how much does the universe see when it looks back at us? You could spend a lifetime searching those archives, trying to separate myth from measurement. The facts are simple enough. An interstellar object entered the solar system, fragmented in unnatural symmetry, and vanished. Its pattern repeated across decades, linked to subtle changes in radiation and motion from the same region of space. A probe sent to investigate disappeared. The evidence ended where the silence began. Everything after that is interpretation, but interpretation is where science and meaning overlap. It's where observation becomes awareness. Somewhere between the raw data and the unease it created lies the truth, that contact might not begin with conversation, it might begin with being noticed. Perhaps 3. Atlas was never meant to communicate in the way we understand. Maybe it wasn't communication at all, but demonstration. A precise act carried out once, designed not to explain, but to teach observation itself. If so, the lesson was simple. You can't observe without being observed in return. The Cassiopeia track remains empty. The telescopes still point there, night after night, recording the same still field of stars. But the stillness feels different now. It feels aware. The sky is no longer something we look through. It's something that looks back. Occasionally, faint anomalies appear. A shift in brightness, a microsecond dip, a trace of rhythm too brief to confirm. Most turn out to be noise, but each one is treated with quiet respect. Because we've learned that the extraordinary rarely announces itself twice. It appears once, behaves perfectly, and leaves behind questions large enough to last generations. The story of 3i Atlas is still told in classrooms, though most of the details are softened. Students learn about interstellar objects, about trajectory and decay. They learn that our solar system is not isolated, that material passes between stars as easily as dust on wind. But somewhere between the lines, the teachers pause. They mention symmetry, regularity, a pattern that didn't fit. Then they move on. The pause is part of the lesson. Even now, there are people who step outside at night and look toward Cassiopeia, waiting for the faint return of that rhythm. They don't expect lights or ships or signals. They're waiting for the familiar feeling of being seen, the same calm unease that once settled over every observatory on Earth when the fragments of Atlas fell into their ordered line. It's been long enough now that myths have begun to form. Some say the object wasn't interstellar at all, but something that originated closer to home and left before we learned to notice. Others claim the pattern was a test, a measure of how we react to mystery, how long we can wait before turning disbelief into curiosity. In the end, those myths don't matter. What matters is that we looked up, and for the first time in history, the universe seemed to look back in a way that felt deliberate. 3. Atlas didn't bring fear. It brought awareness. In that awareness, people found quiet meaning. The realization that if something intelligent does exist beyond our reach, it might not need to visit openly or speak loudly. It can send its message through precision, through repetition, through the kind of beauty that hides inside perfect geometry. That is what remains of the warning we once missed. The message was never "we are coming." it was we are aware. Now, when the night sky turns clear and Cassiopeia rises, those who remember the story still feel a small tension in the air. They count silently in intervals, 90 seconds apart, listening for the faintest rhythm, and though none has been heard again, the habit endures. Because that is what 3i Atlas gave us. Not knowledge, but patience. Patience to look longer. Patience to listen deeper. Patience to understand that silence is a kind of language, one that speaks only to those who refuse to stop listening. So the telescopes continue to turn, night after night, facing the same patch of sky. Not because they expect an answer, but because the act of watching has become its own form of response. Somewhere beyond the stars, maybe that response is noticed. Maybe it isn't. But either way, the exchange has already begun. It began the moment 3i Atlas broke apart with impossible precision, as if to say, "You have seen enough, now learn to wait," and so we wait.